All right then. Hello, everyone. Welcome to the workshop on Git and GitHub. It's during lunch. We're going to keep it pretty chill today, and hope you guys got hyped up by a little music before starting the hand. But yeah, we're going to keep it pretty informal. If you want to turn your camera on, that's fine. Or if you just want to turn it off so people don't watch you munching, that's cool too. But with that, before we actually jump right into it, I want to start off by putting something on our minds to think about. Git and GitHub, these are pretty important tools for software development. Some of you may be interested in computer science and software. That's cool. And some of you maybe are not sure exactly what this is. That's cool too. But my hope today is sort of not only to teach you guys about this critical piece of software, but also to make you guys sort of have an appreciation about, software solutions and the problems that software solves. So I'm going to pose this sort of thought to you before we begin. So, in my hand, I guess if you guys, it's blurred a little bit, but I have a blank piece of paper right here. And when when you guys have paper, right, you write things on that. And when you write things on paper, there's sort of like a psychological or philosophical question that involves in that. What exactly are you going through when you're writing a paper or writing on a piece of paper, right? Well, you have to think about the process. You have to plan. You have, sort of a history of what you have already wrote on the paper and how you may write on the paper going forward. And this is the way a lot of engineers, particularly software engineers, think about when they're writing pieces of software. They have to think about how exactly we as people do things and implement software in a way that could help improve that. So hopefully throughout today, you may see a little bit on why writing on a piece of paper may relate to Git a little bit. But with that, we're just going to jump right in. I'll leave time for questions at the end, but feel free to chat amongst yourselves, in the chat and leave any questions there. And I'll try to come back to it towards the end. But let's jump into it. So here's just a quick overview on what we're covering today. We're going to be covering Git itself. I'll leave a couple links in there on how to download Git and we'll be going over some demos on how to use it. And we'll also be going over a GitHub and also an alternative to using Git, which is called GitHub Desktop. With that, let's jump right into it. So here's just a quick link for how to download Git. I'm just going to leave this up here. Just a couple quick notes. If you're on a Mac like me, you may have already had this piece of software downloaded. We'll show you how to check that in a minute because newer operating systems have that. Windows, you do have to install it using the link here. And Linux, well, if you're using Linux, I think you can use your package manager and figure it out. But let me know if you can't. And specifically for using GitHub through the terminal, you need the GitHub command line interface, which helps you deal with some of the login issues involved. And of course, this is what you can all do pretty easily. If you go to github.com, you can create an account there where you can create your profile and everything like that. With that, I'll leave this reference for you guys to look back at later. Let's jump right into it. So let's talk about Git to start. What exactly is Git? Well, Git is known as a version control system. It's a piece of software that tracks the past, present, and future changes for a particular software project. Now, that might be something a little strange to you, right? You may be asking how exactly a piece of software can know the future. Well, I think we'll try to delve into that a little bit today. In a Git, their fundamental unit of what Git uses is a repository, which is just a folder that contains a bunch of files within it that you change, whether it could be programs in Python, source code in C, etc. Those are all contained within a repository. And the way Git tracks things is through something called deltas. Going back to our piece of paper analogy, right? Let's think about how you would have to track things. If you want to maintain a history, well, a bad way of doing it would be to literally copy over the entire piece of paper to another piece of paper every time you want to change something, right? That would be really expensive, really hard to do. So what Git does is that it uses the changes between two pieces of paper. The changes themselves are called deltas. And an example of a delta is shown right here in this image right here. If you notice that the green sort of indicates lines added to the program, and the red indicates the lines taken away from the program. So that's something you should get familiar with seeing if you try to look through the history of it. And yeah, so the benefit of using Git is it allows not only maintaining a history of it, but it also allows collaboration and asynchronous changes to occur, meaning that multiple people can work on different features and then it can be all merged together in the end. But with that, let's delve into how to use it a little bit. So typically the way you use Git is you start off by clone or initializing a repository. That's a specific Git command you see right over here. Once you download, you type that in your terminal. And this makes a repository or copies an already existing repository. And then once you do that, you always start off by making some changes to check to make sure and to focus on a feature you want to develop. Then you do something called staging your changes. What this means is that if you look in this upper right-hand photo right here, this is an example of staging it. As we mentioned before, the fundamental unit that Git uses is, deltas and the changes between different versions. But the way it annotates them is through commits, which are blocks of changes, blocks of deltas within the history of it. So what this means is that, let's say you change two different parts of the program. Well, you can create a commit that says, well, the delta in this file and the delta in this file, well, they're related to the same change, and we're going to combine them together in one commit. We're going to maybe annotate it saying, oh, we updated a new feature. So that's what a commit is. But before we can make a commit, we always have to stage it because this allows us to sort of going back to the weird statement I made earlier. This allows us to mark our future changes to the software in that we take our changes that we just made and prepare it to be committed. The reason Git does that is just simply because it leaves a level of organization. There are some Git internals we could talk about later during questions, but that's sort of the fundamental basics. And so once you committed that, then the final stage is you can constantly make commits over and over again as you make changes to indicate different things. And then finally, you get to push that all to a centralized repository in the end if you want. So maybe that's GitHub or something like that. So the commands are sort of shown over here. I've listed them. Git init, git clone is creating a repository, as I stated before. Git fetch and git pull, what this does is that it checks a copy of the repository that's stored elsewhere like GitHub and make sure your changes are synced up with that. And then git add, well, that's the key command that shows you how to stage your changes. Git status just does what's up here. It shows you what changes are staged. And git commit creates a commit. It combines those deltas and marks them in the history of it. And as mentioned, git push pushes it to a central repository. I think a better way to help everyone sort of visualize what's going on is through this very cool visualization I found earlier. So does everyone see this change tab? All right. So if you look right here, this is sort of what the Git sort of looks like, or as a high level history, like a high level perspective of it. Each commit is sort of indicated by like this circle, which is called a node. And it marks the sort of different deltas in there. And let's say, well, when you actually use Git, you have to use git add, then git commit, but this visualization simplifies that a bit. So let's say we want to create another commit where we, add another change. Well, if we commit that, well, then, oh, so sorry, I'll allow live transcription. So when you have a commit, right, you can see that it sort of adds to the history of Git in that, your previous commit is marked, but your current change indicates the current state of the software. So, if we keep adding commits as we go, we can see that our history becomes longer as more and more nodes are added, connecting everything together. And so that's sort of the basics of how, at a high level, it's sort of works history-wise. I'm then going to jump into actually then showing you the workflow that you would typically use. So I'm going to then switch sharing my screen to trying to share my desktop. So give me 1 second. If I could just share my terminal, that'd be great. There we go. So if you guys all see my terminal right here, please let me know if I need to make this bigger, because I know it may be hard to see a little bit. I'll zoom up to like make it larger a little bit. So what we're going to do is I'm simply going to go into my documents folder, and we're going to create a new folder just for this demo. Let's call it Git demo. Oh, made a typo. Good start. All right, so let's go into that folder. And get started. All right, so don't worry about if you don't know the Linux command line that well. That's just how I move around. But now that we're in this folder, let's see the contents of inside the folder. As you can sort of see, there's nothing in the folder at this time, right? This is not yet a repository. But let's try to make it a repository. If we git init, we create an empty repository, and if we run the same command again, well, what you can see is that there's this weird folder that appeared, right? That's fundamentally what Git is. It just creates this folder that tracks the history of what your code is through different objects. And so I will say all the commands I use, I'm giving you guys a cheat sheet at the end, so don't be stressed about memorizing it. I just want to put it in front of you to show you, and you can use the cheat sheet as you get used to using Git as you go to practice. So we're going to then just start off by seeing what the history of it is. And as you can see, there's no commits yet. So, what are we supposed to do? Well, let's make some changes. Does anyone have a programming language they want to pick that we can work in? Please give me something common, not something super obscure, so I don't make a fool out of myself. Python. Thank you. I know Python. So, let's create test.py, and let's open that in my terminal editor. Oh, great start already. That's fine. So we're just going to do print hello. Oh, that's great. And so, let me just rename this a bit. There we go. So as we can see, we have a file called test.py in here. And so what I say before, well, let's first stage it. So we're going to use git add-a. The difference is that git add-a, works, makes Git traverse directories upwards and backwards to find all files, while git add star just does everything in the current directory. And then you could also individually do files. You could do git add, in this case, test.py. But I like using git add-a because it makes sure you get everything. So then we're going to see what has been staged. And as you can see, well, we created a new file, test.py. So let's commit it. Oh,
sorry. In the chat, the Git or the Zoom UI is blocking the screen.
Oh, sorry. Do you guys? Oh, is that better?
Yeah.
All right. So sorry about that. Thanks for letting me know. So yeah, there you go. Git add and git status. And now let's commit that change. We're going to use git commit. And the -m flag, well, this allows us to write a message. So let's write a message. Let's say first commit. And then we committed our file. So now we can use git log to see the history of what we committed. And as we can see, well, there we go. We created our first commit in a repository. Yay. Now, so that's your typical workflow. Now, let's say, for example, you want to push it yet. Well, this will kind of demonstrate some of the very great parts of the Git software in that, as you can see, I can't push it because it doesn't know where the repository is. So once I'll do that when we get to the GitHub part, but as you can see, Git is very good when you're starting off using it because it gives very descriptive error messages on what the right commands are to use. But with that, I'm going to switch back to the slides, and we're going to keep on going to the next part. So that's Git at a high level. And now we're going to move on to GitHub. So GitHub is a website that's meant for software development and version control management. The way it does it is that it hosts Git repositories in addition to providing collaborative software development tools. We'll show you some of those tools in a minute, and we'll show you how GitHub hosts these repositories on there. GitHub supports free and open source software. If you're not familiar with the term FOSS, which is good because if you're interested in getting into open source projects or building a professional software portfolio, well, GitHub is a great place to do that because it's all for free, and it's all if you choose to make it public, it's great on the internet. So we're going to talk then about how to use GitHub. So just to highlight a couple terminologies, branches are things in version control history, version control history like Git, which just indicate different flows of commits, right? There's two different linear histories as people work on their own thing. And merging is when you combine those two different histories together on a singular branch. Issues is a GitHub feature that just allows you to mark problems, as you can see in this upper right-hand corner, in a very detailed tag manner. And pull requests are ways for you to get approval for the branches and help you merge things easier. You can merge things using Git, but it is a little bit difficult if you are not too familiar with Git. But with that, let me switch over to GitHub. And we're going to start off by, let's creating a repository. So if you go on GitHub for the first time after logging into github.com, you're just click on create new repository. For simplicity's sake, I'm going to make a public repository. So I'm going to call it Git demo for now. And I'm going to make it public, and I'm just going to make it completely empty. If you choose to make it private for your project, please make sure to download the GitHub login CLI because you may run into some issues with authenticating pushes. But with that, let's create this repository. And once you do that, as you can see, okay, well, we created an empty repository right here. So now let's try to push our existing code to GitHub. So I'm going to copy this link, and I'm going to stop sharing for a second as I switch back to my terminal. And if we switch back to my terminal, as you can see, we're going to run the command that it told us earlier. We're going to run git remote add origin this link. And so it should do that. And so when I push, one thing, as you can tell, Git is very responsive at giving us error commands. And so when you do that, when you push that all the way, actually, it may be easier for me to just share my entire desktop. Give me a second. All right. Once I do that, right, you can see if we go back to GitHub and reload the page, we have our source code on GitHub, right? And, highlight a couple of features, you can see, the diffs of your commits that you made and etc. So let's start off by, creating an issue. Pretty straightforward. Just click issue, first issue. Maybe you want to assign it to someone in the project, myself, and we just spam a little bit. And you created first issue. Then let's say we want to create a pull request. Well, this requires to create a branch. So before I create a branch on my terminal, let's go to the visualization a bit to understand what exactly branches are. So let's start off by creating a branch. So there are a couple commands you can use. You can use git branch, and I think the name of it or something like that. But I recommend using git checkout -b. This allows you to switch to the branch that you are branching off of. So I'm going to call it branch 1. And you can see Well, it creates a branch which currently has, just at the same point as, the master branch. But let's say we create a commit and then it starts, going forward, diverging from the master branch. And, let's then go back to the master branch where we're now back here in changes and we want to make more commits on the master branch. And as you can see, there are concurrent changes happening at the same time at different rates, which Git allows, but it has connected history. It has connected linear history, which is sort of the concept behind it. And even further is you can, continue to check out even while you're at this certain point. And, let's say we're on branch 2 and we go there and we make more commits. Well, that's, sort of how it works. And, we can keep going back and forth having multiple people working on the project at the same time in a unique manner. And so beyond that, the other thing I mentioned earlier was merging. We can also merge it. I'm going to use Git, but I'll show you how to use it on GitHub, which is a bit easier. If we merge, we can merge, say, the master branch with branch 1. I think I'm on, what branch am I? Okay, I'm on the master branch. So I'm going to then merge branch 1 here. As you can tell, we connected the history of the branch 1. Those changes are now on the master branch. So this shows you how to combine features developed separately on different branches. So with that, let's do that inside our terminal. So I'm going to clear my terminal and let's create a branch. Well, let's first see the existing branch, right? We have the existing branch is called main. Let's check out branch 1. And now, as you can see, we're on branch 1. And now we have to create some edits. Let's go back to test.py and add another line. Let's say print GSET is so cool. And once we do that, we can, another cool command you could try using is you can see git diff. And you can see what your current changes are that haven't been staged yet. So let's stage it. And then commit it. Oh, and then you can always check what you have staged using git status. And you can see we've modified it. Let's commit it. And let's push it. And it's going, oh, of course I created a new branch, so I need it. I need to handle merging here. So GitHub now has an up-to-date version of the code. So with that, I'm going to then just briefly show you that the history now looks like this, but if we go back to the main branch, well, the history still looks like this, only one commit. So let's now go to GitHub and let's go see where everything is. If we go back to the main page, you can see, oh, wait, there are now 2 branches in this project, branch 1. And if we go to branch 1, well, we see, well, it has the new changes. Now let's try to create a pull request. And what a pull request is that it creates this request for you to merge a branch where you developed a feature onto a different branch, whether it be a side branch to combine the features developed at the same time, or the main branch. Let's create a pull request, and we should compare and pull that. And if you're having the issue I had before, just make sure you have branches that are different. Otherwise, it may be a bit confusing. So what you do is you simply, add some description and you create a pull request. Simple as that. Now, what this does is, if you can see here, it attempts to compare the 2 different branches, see what's different, and then proposes changes to that. So you could typically ask for a reviewer if there was someone else in my group in the project here, and you could do a review of that, checking to make sure everything's okay. Now let's merge it. So just simply merge it. With that, I'm not going to delete it for now, but as you can see, if we go back to the main, well, there you have it. Everything is on the main branch, as you can see right here. And so what we just did was we developed a feature and combined it, which is pretty great, pretty neat. And as you can see here, there are, a history of commits. The reason there is a commit here is because we created a merge commit that indicated that we combined 2 branches together. But that's it. What you also do is you could link issues to branches so that they close. I should have done that before, but if you link it to here, then once you approve this and merge it, this typically closes. Oh, as you can see right there, it closed it automatically. And so there we have it. We then have, oh, I should probably just close this issue. And there we go. We have no more issues left, which is pretty neat. And so, yeah, that's sort of the fundamentals of using Git. If, for example, other people working on the project and pushing to the same GitHub repository as you, well, what you would do is anytime you start to make changes, you would use Git Fetch. What Git Fetch does is that it compares it with, the origin. Oh, as you can see, we made changes on GitHub, so it, got those changes. But I believe if we check out to main, oh, we're on main. Check it out. As you can see, well, wait a minute. I did a Git Fetch. Why is the main branch still the same? Well, the reason is Git Fetch does a comparison. It lets you know if there are existing changes from the repository on GitHub. And so what you would actually do is you would do Git pull to update your repository to that. And once you do that, well, if we do that, well, as you can see, well, our repository updates. I guess one Git command I'll quickly highlight is git graph. Oh, git graph. Oh, one line. There we go, which is a pretty neat internal visualization of the commits. But of course, this is the same visualization as what we used online. And so with that, let's go back to the presentation as we finished the GitHub demo. And I'll briefly highlight GitHub Desktop. Let's say, I know many of my friends are like this. I have a friend working at Meta this summer, Facebook, who hates using the Git terminal and really likes GitHub Desktop. Then I recommend using this as an alternative. Basically, GitHub Desktop does everything that we just did, but with a nice user interface. You can just click everything and it automatically prompts things for you and makes it pretty easy to use. So if you're uncomfortable with using the terminal, completely fine. Just make sure to download GitHub Desktop, and yeah, that'll make things easy for you. So I want to sort of, try to close up by highlighting a couple extra, software project tips for, developing your first, larger project or more important project. A couple things I want to add is, always make sure to maintain good documentation. As someone who coded a little bit in high school and definitely, in college as well, the biggest pain always is remembering what an old project did, right? You're like, man, I created this cool project in class many years ago, but I don't remember what exactly it did. Well, adding documentation that not only helps you remember, but also helps people understand that. And the way you do that is by adding a file called a README to a repository, which GitHub will then present to other people and make it easy. I'll just show you one example. If you go, let's say, does anyone have a favorite piece of software? That's a weird question. I think outside that.
What, like a GitHub repo?
Yeah, sure. Anyone have something their favorite? Next.js. All right, that's a pretty nice one. Let's see if we can find it. Oh wait, hold on. I gotta search all of GitHub. There we go. Next.js. And if we go here, as you can see, well, this is a pretty big important project. They have a really nice README right here, which tells you everything about the project itself. Pretty cool. And you want your projects to be documented in a similar manner. And you're going back here. A couple things you also want to think about is the license you choose for your thing. I don't want to get too much into the weeds of it, but I would be careful because the MIT license, which is often default on projects, it's very helpful for software in that it's because it makes everything open source. But make sure that you're not signing away code that you personally don't want to give away. And the last thing I recommend is choosing your dependencies wisely, which is simply just the libraries that you depend on in your software project. If you're looking for software to use, besides Googling, another great way to use GitHub as a tool is to look at the stars, which is just sort of ways to support projects. And also I recommend starring things you really like as well on GitHub. This way that, open source contributors know that, man, my project really is working well. And the last thing I want to sort of note is that, as a sort of lesson on life, but also a lesson on Git itself, don't be afraid to commit. I know a lot of people are very scared for the first time using Git, maybe unfamiliar, or they're like, oh my goodness, my changes will be marked down somewhere, forever, and that's scary. Well, don't be afraid to commit. Like just hop to the next slide. The only way you can get to become, truly someone involved with software is just by doing it. And you can't do that by being afraid. You just have to go for it. And so as you can see here, this is not mine. This is just some random image I found on the internet. This person, wow, has quite a bit of commits. And so in order to get there, well, you have to do some of these commits. The reason I took this photo on the right, this is from the Git Hub History, the Git history of one of the projects I worked on recently with friends at a hackathon. As you can tell, the Git history here is not exactly very clean and often very strange. As you can tell here, my friend, this was like an hour or so before the end of the hackathon. So it's like my friend went, help. There's like a couple of few features. my friend here just did a keyboard spam, and oh, this is my favorite personally. One of my group members made a branch called "This Is Not a Branch" and merged that into here. And of course, this one is the best. It's so late. It was so late. It was very hard and tired. But with that, I hope that not only makes you guys feel more comfortable about GitHub, but also makes you more confident to commit for the first time. So with that, I'll take any questions, and I'll highlight at the end of this slide that I left a couple resources here. If you need, a cheat sheet, and if you want to also read more about different kinds of commands, then you also look at Git plumbing, which is how Git works at a lower level. But with that, I'm going to then stop sharing my screen. I'm then going to pause the recording if I can find where my Zoom bar went. And